Hello everyone. Today we are going to talk about rational functions and their graphs. First, what are rational functions? Well, I'm going to use letter R sometimes to talk about rational functions. R of x is going to look like a ratio or fraction of two polynomials, p of x over q of x. I'm going to start with a very simple example. Example number 1. I'm going to choose my first function as a 1 over x function. We already know how the graph of this function looks, right? I'm going to briefly graph it. So guys, we know that when we have very, very large x over here somewhere at infinity, we're going to divide 1 by a large number and get a small number. I'm going to write it down. 1 divided by big number. Almost 0. So we're going to have something like this. Now, if we divide 1 by a very small number, we are going to get infinity or a very large number. Imagine you divide, for example, 1 over 0.001. Actually, it's going to give us 1000, right? I'm going to write it down as infinity. Infinity means that the number is a large number. In between, we are going to have something like this. And over here is going to be 0.11. For negative numbers, everything is going to be same, but negative, right? The small and big numbers are going to be just negative numbers. -1 and 1, right? What important lines we do have on this graph? Important line number 1 is called a vertical asymptote. I'm going to mark it in green. Dashed line in green. What is vertical asymptote? X equals 0 vertical asymptote. Vertical asymptote means that function goes to infinity nearby that. So when x goes to 0, either on the right, which is going to be labeled as plus, or x goes to 0 on the left. I'm going to label 0 plus and 0 minus here. F of x goes to infinity, either positive or negative infinity. Then we are going to call this line vertical asymptote. Well, infinity means big number. Now, one more asymptote is going to be a horizontal asymptote. Horizontal asymptote is going to be a horizontal line, which I'm marking right now with blue dashed line. And that's going to be y equals 0 because it goes through the point y equals 0, right? I'm going to label it horizontal asymptote. What is horizontal asymptote? Horizontal asymptote, it's a line to which function approaches when x goes to infinity. Here, x was going to 0 plus. Here, I'm going to put x to positive infinity somewhere here. And you see that function is getting close to 0, right? So f of x close to 0. When x goes to negative infinity, over here, I'm going to label negative infinity, positive infinity, x goes. Then f of x again goes to 0. This line y equals 0, can be any other constant, is called a horizontal asymptote. Okay, we are going to use vertical and horizontal asymptote for other graphing too. Let's see now how the graph is going to be modified if we kind of have it a little bit more complicated. So example number 2. F of x equals 1 over x minus 1. So how are we going to modify this graph? Well, remember transformations. Transformations, when x, we subtract something, means that we are going to shift the graph 1 unit to the right. 1 unit to the right is going to mean that the graph is going to shift everything 1 unit to the right. For example, vertical asymptote, which is a green, goes through x equals 0. Now we'll go through x equals 1. So x equals 1 vertical asymptote. Well, guys, how can we see this without transformations? You see that if you plug in here x equals 1, you are going to get the denominator equals to 0, which we cannot allow. Well, that's going to be a vertical asymptote. Well, the rest of the graph is going to be same, so I'm just going to kind of repeat the graph. Okay. Now, what if we transform now the graph one more time and graph x minus 1, let's say plus 2. So plus 2, it's a vertical shift up, right? And what are we going to shift vertically is going to be horizontal asymptote. We're going to shift everything vertically up, but the horizontal asymptote, which sits over here, is going to be shifted 2 units up. So let me do the coordinate plane first. And then I'm going to graph my horizontal asymptote 2. So it was over here at y equals 0. Now it's at 2. My vertical asymptote is going to be same because I'm not moving it in horizontal direction. So it's going to be 1. So x equals 1 vertical asymptote, y equals 2 horizontal asymptote. Now I'm just going to repeat my graph. Well, see that graph is now approaching the asymptotes. It's not approaching axis anymore. So that's x and y. It's approaching actually different lines. Why does it happen? Well, imagine that x goes to infinity here, a large number. Infinity minus 1 is still infinity, right? 1 divided over infinity, almost 0. And then the function is going to be 0 plus 2, which is going to be almost 2 over here and almost 2 over here. So that's how we graph it. Now, guys, I'm going to consider one more example of graphing of this rational function, simple rational function, and then I'll ask you to graph something on your own. Let's imagine that now f of x is given in a slightly different form, 3x plus 5 divided over x plus 2. Well, it's now really hard to say what was shifted and which direction because it's not in a standard form like x plus or minus something plus a function plus something, right? It's not looking like f of x minus a plus b, where a and b are going to be vertical and horizontal shifts. Now, it's because it's not in this shape. We will need to bring it to this shape. How are we going to do it? We're going to do division. So I'm going to put my denominator and numerator here, denominator here, and just do division like we were learning in like synthetic division you can do, or you can do long division. I'm going to do long division because it's just one step actually. So I'll need to multiply x by 3 to get 3x, right? And then subtracting is going to give me minus 1 here. So my function is actually 3 minus 1 over x plus 2. I'm going to rewrite it in a form like I had before over here. So I'm going to write it like this. Minus 1 over x plus 2 plus 3. Now I'm just going to define my transformations. So first we have 3 units up from over here. Second, we have 2 units to the left from over here. And the third one, we do have a reflection about x-axis. Why? Because we have a minus. Let me kind of show it, a reflection about the x-axis. Well, guys, what I'm going to do, I'm going to draw reflection first to show you like how reflection is going to look. And then I'm going to draw asymptotes and just put reflected graph in them. So normal graph looks like this, right? 1 over x. How reflection about x-axis is going to look? Well, this point, for example, is going to be here, right? Reflected. This point is going to be here. This point is going to be here. And that's going to be my reflection. This one, this point is going to reflect over here about x-axis, right? It's like the mirror is over here. And all other points are going to be reflected. So my reflected graph is going to kind of take other quadrant. Now I'm going to graph actually what happens to my asymptotes and just put reflected graph inside. So my vertical asymptote is going to be what? It's going to be shifted 2 units to the left. So that's going to be my vertical asymptote. My horizontal asymptote, 3 units up. So these shifts are applied to asymptotes, but actually because asymptotes are like a frame holding the graph, they're going to be applied to the graph too. Now I'm going to put my reflected graph in kind of between the asymptotes. And that's going to be my graph. Now you need to label everything, right? And you will need to write down that the vertical asymptote x equals 2. And I'm going to use blue color, but it's not necessary. Horizontal asymptote y equals 3. That's all you need to do to graph it. Now, guys, I want you to graph something similar. So self-work. Please graph f of x equals 5x minus 10 divided over x minus 3. Find vertical and horizontal asymptotes. Graph. As usually, I'm going to give you like 10 minutes to do this, and I'm going to just count to 5 and show you solution, but my suggestion is to graph it yourself first. Okay, so 1, 2, 3, 4, 5. Solution. Well, I'm going to do first division to find out like how it's going to look in a standard form, 5x minus 10. Again, I'm doing long division, but you can do synthetic division. It's just one step going to take same time long division or synthetic division. So 5 over here, 5 by x is 5x minus 15, right? If I subtract it, I'm going to get 5 over here. So actually my f of x is 5, this one, this 5, plus 5 over x minus 3. Well, happens sometimes. So what I have this one is going to be shift up, right? And this one is going to be shift to the right. Well, this 5 is going to mean that I'm going to stretch my graph in the y direction. Well, usually you're not going to see it very directly on the graph, so you just graph like normal. We don't need to reflect anything because there are no minuses. So I'm just going to graph it very briefly. So 5 units up, 1, 2. Guys, I'm going to actually use a smaller units. Otherwise, 5 is going to be almost here. 1, 2, 3, 4, 5. Okay, let's do it here. That's my 5. My horizontal asymptote moves 5 units up. My vertical asymptote will move 3 units to the right. 1, 2, 3. This is 3. This is 5. I'm going to write down from my picture that x equals 3 vertical asymptote and y equals 5 horizontal asymptote. Now you just graph your standard graph. It's going to be a little bit more slim over here. Okay, but otherwise it's basically very same graph. Okay, if your graph looks like this, you are fine. The graph never intersects horizontal asymptote or no, for horizontal it can intersect, but not this one. For vertical asymptote, it will never intersect vertical asymptote. Okay, guys, that's the end of the first part of this lecture. I decided to split this lecture in 3 parts because they are a little bit different and I want you to mix them up. Okay.